Hello, welcome to the second lecture on microprocessor and microcontroller. In the last lecture, we just saw a brief outline regarding what an 8085 processor is, and we went through each of the components of the internal architecture or internal blocks one by one. Now, in this lecture, let's put everything together and have a complete picture regarding that. Okay. So this is a complete block diagram of the processor, internal architecture of the processor. So this is a logic diagram, okay, logic level diagram, it's not circuit diagram. So out of this, you saw or we explained what this register part, right? We discussed regarding the registers. We discussed regarding the registers. So out of that we discussed this one, the B registers, B, C, D, E, H, L, stack pointer and program counter, right? So out of this, what is this multiplexer required for? What is the purpose of this multiplexer? Because what is a multiplexer anyway? Multiplexer is used to take in multiple inputs and give one output. So here the multiplexer, one end of the multiplexer is connected to the registers and the other end is connected to the data bus, internal data bus. So just guess what will it be. Right, here we have certain number of registers as the input and we want to give the data to the data register, right? Sorry, data bus. So depending on the control unit's control demand, one of these registers will be taken, values within this register will be taken to the multiplexer and will be given to the 8-bit bus. Similarly, data coming into the registers, so it will be coming through this line and it will be taken here, and from here it will act as a demultiplexer and will give to some of the registers. And there are two temporary registers, W and Z, that we didn't mention about. They are temporary registers which are internally used and not accessible to the programmer. Okay, then there is a register select. To select, this is a logical mechanism to select which register is to be used depending on the control coming. Okay, so then there is two things, the increment bar decrement. Okay, let me just write it here. Increment bar decrement and address latch. Address latch. So this address latch, the concept of address latch we will deal with in detail, much detail later. Just know that it is for the purpose of keeping the address when we are using some lines. We will come to that later, don't worry about that. So the increment and decrement part here, that is used usually to increment the program counter, right? Why? Because every time an instruction is executed, you have to increment the program counter, right? Also, if you have the stack pointer, there is pushing and popping happening, you have to increment and decrement the stack pointer. So instead of using the ALU for just adding one or subtracting one every time, you just given a dedicated increment bar decrement hardware along with the stack pointer and program counter. The address latch, we will come to that later. Okay. Then there is this address buffer and data bar address buffer. Okay. So we have said that the program counter points to the next instruction to be instructed, to be executed, and we can use the HL pair as an data pointer, right? So that means we have some address in this registers, some of the registers, and we want to pass it to the memory. Similarly, once we have identified the location and we want to write some data, right, or we want to read some data from the memory, that is we want to take some, give some data or take some data, there should be some interaction between the outside world, and that is the memory external bus and the internal bus, right? So it is not like we are just directly connecting the two buses together. For that we are using some bus. So from the program counter or the HL pair, we are not directly connecting them to the external bus. There is something called as an address buffer that is used, that is the address from the PC or the HL pair, it is first taken and stored here in the address bus, address buffer. So it is a 16-bit. So these are two 8 bits. So we use this combined 16-bit as a address buffer. From there we give it to the external bus. Similarly, whenever data is there, it is given here to only this one. Okay, for data this is not used, only this is used for a data. So this has a dual purpose. So this is sometimes used as an address buffer, lower bit of the address buffer, and sometimes it is used as a data buffer. So the concept of address latch also comes in this part. We'll deal with it later anyway. So just know that combined these are used as a buffer for address, that is once it is going out it is stored here, then only it is given to the external world, and whenever data is coming it is stored here, then only it is given to the external world, or if it is coming in it is stored here, then only it is taken to the internal bus. So that is the purpose of address buffer and data buffer. Okay, so we have covered this portion. Now okay, this one you know, the instruction register and instruction decoder. This machine cycle part we will come to that later. That is a portion of itself. Okay, so the flag flip-flop means flag registers. Like flag register we are done with it. ALU we have covered. Temporary register and accumulator. Okay, so then there is an interrupt controller. So what is an interrupt? You know what an interrupt is. Anyway, we will deal with the interrupts one by one. So interrupt is anything that interrupts the current flow of execution of instruction, and it will ask the processor to do something else. That is an interrupt. So this 8085 has a certain number of interrupts and they are connected to the interrupt control. Okay, and then we have the serial IO control. IO is for input output devices. So serial IO means there is whenever we are talking about data transfer, it can be in parallel mode. That is if we have say 10100001, if this is our data, we can send all of this at once at one go. That is called as a parallel, or we can give transfer one by one, 1000 like that. That is called a serial. It depends on our purpose. Okay, anyway, the thing is that 8085 has a provision for serial communication, and it has a dedicated control here, and the input outputs are given here. And there is the next thing is the timing and control. So all the other signals, okay, all these are pins which are connected to the outside world. Okay, all these interrupts, serial in, serial out, this address AD7 to AD0, A15 to A8, all these things are pins. So these pins are given to the relevant parts. So whichever is remaining, it is given to here. We will study all of these pins one by one in our later lectures, and then we will go through their functions one by one anyway. So just understand that in this timing and control, even though many pins are coming, they are also somehow grouped. Okay, for example, this X1 and X2, that pertains to the clock input. This one is the clock output. Then there is the certain control signals and status signals. Then there is the concept of DMA, direct memory access. Okay, then also there is for resetting, signals for resetting. We will come to them in detail. So this is a complete architecture of the processor. Don't be alarmed or intimidated by it. Let me just clear off the lines. Okay, so actually it's when you want to learn it, it's pretty much simple. Okay, just start with the accumulator. Okay, start with the accumulator. So accumulator needs some input. So one input comes from the temporary register, the other comes from the ALU. We start with the ALU, my mistake. ALU needs two inputs. The temporary register is 1, accumulator is 1. So inputs are given. And now we have to give the output. Where will we give the output? We give the output to the data bus. And where will the accumulator and temporary register take the input from? It takes from the data bus. So we start with the ALU. We have established these two, the connection, and we establish the data bus, right? So ALU, our temporary register, our accumulator. Okay, so these two we have established, and we want to give the output. Okay, that also we have established. Then after that we draw the internal bus. Okay, we draw the internal bus. Then we just wind off, complete the ALU part with the flags. Okay, once we have done that, then it is just we have the instruction register area. We have the instruction register area, that is one. Okay, remember which all are bidirectional connections and which are all unidirectional connections. Okay, then we have the instruction register followed by the instruction decoder, which is given to the timing and control. Okay, it's given to the timing and control. Then there is the register array. It is called as a register array. Okay, register array, this whole thing. So we have our ALU part, ALU area, our instruction register, instruction decoder area, our register array area, and from the register array we have to give the address buffer and data buffer. Okay, then it is just a matter of interrupt control, serial control, and timing and control. So as far as the drawing of this thing is concerned, it's better if you have a strategy. Like this may be asked in the exam, there is a chance. It has been asked in the previous exams. So just have a strategy regarding how you draw. My personal suggestion is that you start from the ALU region, establish the bus, then go for either of the registers or instruction register part. Okay, then from there build. Okay, let's start small and keep on building. Okay, so that is regarding the internal architecture and the components, internal components of the 8085 processor. So I'm stopping the lecture here. From the next lecture onwards, we will in the next lecture we will start with the pin diagram of the 8085 processor, and we'll discuss each pin one by one, like we discussed some of the main components of this architecture one by one. We will discuss the pins one by one, what they are, what their names are, what their functions are, and whenever we are discussing, sometimes when we are discussing some pins, we will have to consider some concepts also. Okay, so we'll go by that. Thank you.